Step 2 of creating a printed circuit board is to create the actual PCB layout. So I'm going to add a new PCB into my project. So a few things I need to point out about this window. So we navigate in the same way as the schematic editor. So that's right click and drag to pan around, and control and scroll wheel to zoom in and out. There's a few layers across the bottom, and the most important ones to understand right now are the top and the bottom layer here. So these refer to the copper, so the electrical connections on the top and the bottom sides of the circuit board, and also the top and the bottom overlay. So overlay refers to the silk screen, so this is the artwork that will be printed onto the board. The other layers we will come back to in kind of future learning about PCBs, but that's the most important right now. So the way that we navigate this window, you'll notice that there's a display in the top left here which displays the coordinates of the X and Y coordinates of where my mouse cursor is, as well as a DX and a DY. So that is since I clicked. If I click somewhere and then move, that's sort of the change in X and Y. Now the units right now are mils, which is a thousandths of an inch. So if I press the Q key on my keyboard, then I toggle between inches and millimeters as my reference. And so we tend to work in both system of units in printed circuit boards, so it's useful to remember that Q key to actually switch between them. So the first thing that I need to do is define the size of the printed circuit board that I would actually like to make. And this default board here is fairly large, so I'm going to actually redefine the board shape. So to do that, I need to teach you about the board planning view. So if I press the keys on my, the number keys on my keyboard, so 1, 2, 3. So these are the number keys on my keyboard. I scroll through 3 different regions. So number 1, it's called board planning. That's how we define the size. Number 2 is where we lay out the components. Number 3 is a 3D rendering of what our printed circuit board is going to look like. So coming back to the board planning view, what I need to do is define the board shape. So there is a redefined board shape here under design. Now to do this, I'm going to basically click and drag to make the shape of my board. But I would like to do that working in millimeters, so I'll change my units. And I would also like to use a very large grid spacing. So I'm actually going to press G to open up this grid menu. So the grid spacing means that every click that I make will be rounded to the nearest multiple of whatever I select here. So I'm actually going to choose a custom value here as really massive grid size, let's say 10 millimeters, which means that every click will be rounded to the nearest 10 millimeters. Makes it easy to define the shape. So click, I will come across, I'm looking in the top left corner, I see my X coordinate is 30 millimeters, so I've come across by 30 millimeters. I'll click, I'll come up 30, across by 30, click, and then a right click to end. And so I've now defined a 30 by 30 millimeter square, which will be the shape of my printed circuit board. I usually do this with respect to the origin, so this symbol here is the origin of my coordinate system. Put that in the bottom left corner of your board. So pressing the 2 key, coming back to now the electrical design, let's go and actually lay out this board. So firstly I need to save this file, so Control S and save. Now I need to bring in the actual components from my schematic. So that is design, import changes. So it comes up with this list of all of the things which are different between the PCB and the schematic. And right now, this PCB is empty, so there are many things that need to be added. So that all looks good to me. I'll press execute changes. And so what this will do is bring in all of the components that we had previously defined in our schematic. And they have been placed into this red box here with the label main. That comes from the name of the file of my schematic. And this object here is called a room. And so the intent with this is that we can define certain regions of our printed circuit board that will relate to certain aspects of our circuit. If you have a complex design, you might have multiple schematics, and so you might want to reserve portions of your board for certain parts of your project. In this case, I have one, and so I'm just going to set the room to be the entire size of my board. If you don't want to use the room feature, you can actually just delete it. So just select it and delete. But I'll leave that feature in for now, just to show you how it operates. Now I have the components themselves, and right now I'm still using that very large grid spacing, so it's kind of hard to lay things out. So I'm going to switch to a smaller grid size, and I'm going to work based on inches for laying out these components. And the reason for that is that the distance between the holes in my header here is 0.1 of an inch. So it kind of makes sense to use a grid system based on inches when you're actually choosing where your components should go. So how am I going to lay out this board? Well, this was my power input. If I zoom in, I can see the names of the nets which I defined. So for example, +12 ground and -12, so I can kind of see what I'm working with. Spacebar will allow me to rotate, and I'm going to put the power input, say, at the top of the board over here, and just bring that P2 label over to the side. So the yellow color here refers to this top overlay, so that is the artwork that will be printed onto the actual board. Next, I will grab the other headers and just arrange those somewhere reasonable. So input can go on the left-hand side, and the output I will put over here, somewhere like there, on the right-hand side of that board. Now, if you see this green color, notice how this resistor here is set up in green. Green means that there's a problem. So strange counterintuitive colors, green means bad. So the problem here is that it's outside the room. If I bring it in, it goes to red, which is nice, happy top layer copper, which is where those pads are. So let's go and lay this out. I will putting the components somewhere. Basically, what I'm trying to do here is make sure that these air wires, so these lines here indicate the air wires that connect the different components together. I need to make sure that they don't really cross over each other too much, because that will make it more difficult for me to actually lay out the tracks. So for example, this resistor needs to go towards, say, this side of the integrated circuit, so good position would be to put R2 somewhere there. This one also connects over here, so that would be a reasonable place to put that component. My capacitor here I will put on that side, and this one can go, say, here would be a reasonable place for that, so that there the air wires are fairly nicely not crossing over. So that's the layout that I'm going to use for this. Now, another thing that I should do at this point is put some holes in the corners of the board. So if I look at my 3D rendering, so that's what my board's going to look like. You might say, well, this has got to go into a box, or it's got to fit into some kind of product. We need some way to physically attach it. So I can do that by placing a via. So place menu via. Just like the PCB editor, I press tab. So tab pauses my movement and brings up this properties window. So over here, I can specify some details about this via. So in particular, the hole size. So I would like to, let's go with a 2mm hole, so that I could use an M2 screw to affix this PCB to the case. And also the diameter. So this refers to the copper, exposed copper that will be presented around the outside of that hole. And so I might say 4mm. For that. And I would like to place these on the edges of the board, but it's convenient to do that in a grid which is based on millimeters, because my board is based on millimeters. So I'll change to a 1mm grid spacing and choose locations on the edges here, here, and here. And I'll change these labels, move these labels down to get them out of the way. I'll just change my grid spacing back, move these labels down to get them out of the way of those holes. So having a look now, 3 key on my keyboard shows me the 3D rendering. That looks much better. I now have some kind of mechanical way to attach my circuit board into the case into which it will be placed. So the next step before I go and lay out any of the actual tracks is to make sure that I have my design rules set up. So design and rules, and there are actually many different things here which you should go through and have a look at. And basically the idea of this is to match it up to the requirements of your manufacturer. So your manufacturer will have some specifications as to things like the track width and the clearance and so on, which they are able to support. And so you need to make sure that you are designing your board so that it lines up with the requirements of whoever is actually making it. Because I currently working in millimeters, these clearances are all specified in millimeters. I'm going to switch to inches, so the Q key, and come back into design rules. So now I see that's 10mm clearance right across here. Now I can change them all at once using the minimum clearance setting at the top here. So if I wanted, say, 12mm clearance, I could just type 12, press enter, and you see all the numbers in this table will change. But actually 10 is pretty reasonable, so I'll go back to that. Another really important setting is the track width. So again, the minimum track width 10 is fairly generous for a commercially made board, so we could usually go smaller than that, but I might as well leave it at 10. This is a very, very simple design. I don't need to push any limits here. The maximum can be much larger. Let's say we allow 0.5 millimeter, so really quite a huge track width for the maximum size. And of course, there's many other settings as well, and you should really line these up with the capabilities of your manufacturer. So with the design rules set up, I will now show you how to actually run the tracks, or we call it routing the tracks. So there is a tool here, interactively route connections, or Control W. So these are drawing the electrical wires. So for example, here I have this signal input, so I can click on this pad. I now am kind of running one of the tracks on my printed circuit board. If I press the Tab key, I get to see the properties over here, and I get to change the width. So in this case, I'm using a 10 mm wide track. That's good for this purpose, so press Enter to accept that. And I'll come across, and you see it highlights the pad over here that I'm aiming for. So happy with that one. I'll come out over here. Click, and now I've run that track which connects those. So now I just keep looking for the other air wires and start making connections. So another thing I'll show you, if I hold the Shift key, and put my mouse cursor over one of the pads, you see it kind of highlights all the other pads which belong to that same net. So that helps me see that I need to actually connect from there to there and then across to here. So let's run that first connection across. And now you see I need to go over this other connector that I already drew. So of course, top side of the board, if I was to try and run a track through here, it would be a short circuit. It's actually not going to let me draw that because it would be shorting these two signals together. So I could kind of go around the outside like this. I'm going to cross over this one. So how can we actually deal with that? Well, one thing that I can do is change to the other side of the board, and this is a feature called a via. So I do that. You notice on the bottom side I can see top layer, bottom layer. If I press the plus key on my numeric keypad, so this is the plus and minus keys, they scroll towards the top and the bottom, so plus towards the bottom. I have only 2 layers here, so there's only 2 to scroll through. I'm now on the bottom layer, and it's automatically inserted a via, which is a hole through the board that will be plated with metal on the inside to create a connection. So if I click, I'm now working on the bottom side of the board. I can now come across and make this connection over here. Now because this is a through hole feature, this is a hole, it's connected to both sides, so I can actually connect it up on the bottom just like that. So I've now connected this net through here by using that via. I'll come back, so minus key, come back to the top layer and keep going with some of the other connections that I need to make. So connecting these ones up. Minus 12 net comes into here. Where else does it go? It goes up to the top there. So I could go around the outside here and up and make that connection. Now I'm leaving ground. I'm not connecting ground right now because I'm going to fill that in later with a feature called a polygon. So I'll show you how that works in a moment. But for now, let me just finish off these other tracks which I need to run. So my plus 12 net can come up to there. Let's have a look at what else. So I've got these little ones here which need to be connected. So I'll connect those up, but I'll leave one off. I'm not going to connect these. I'm going to show you how you could actually catch that kind of design mistake if you forget to actually connect up some of your connections. So I'm looking at these. The other things I can see that are not connected are all the ground, so that's all okay. I'm going to use the polygons to make that ground connection. So I'll press escape to get out of that routing tool, save my file, and now I'll show you about how we can use polygons. So a polygon is what we place on the rest of the board. So kind of this region out here. Like, what is all of this? There's nothing out here. This is where the polygon is going to occupy. So there's a draw polygon, so I can go place and polygon pour, and then I can actually draw some kind of shape, and that will make a shape of a certain size. And you see I've kind of filled in this region here with copper. But I actually don't want to do that. There's a smarter way, a faster way, and that is the Polygon Manager. So Tools, Polygon Pause, and Polygon Manager. So in the Polygon Manager, there is a button here that says New Polygon From, and you can choose the board outline. So I want a polygon that traces around the outline of my board. Now I would like to place this polygon into the ground net. So this is very important. A lot of new PCB designers might forget to change this setting. If you have a polygon that's not part of a net, then it's not connected to anything. It's not part of your circuit. It's kind of useless. So top layer, I'll just tick this auto naming, and that random name there is okay. I'll hit apply. And so what this has done is calculated this whole region of copper here, which will fill the whole top side of the board and will be connected to the ground plane. So you can see the header here, here, and here, which was grounded, that the polygon actually has come in and made contact there. So this is electrically providing that ground plane or that ground connection. And do the same thing on the bottom layer. So I create another polygon. I'll put that one on the bottom layer. I'll select the ground net for that one. And this naming is not very meaningful. There we go, it's ground. Let's apply that one. And we have now bottom layer polygon as well, which is going to create all of those connections for us. So let's press OK, and we can now have a look. So top layer, we have this polygon everywhere, and the bottom layer. Now one thing that I want to look for is to make sure that I have good connections, that I don't have any isolated regions. We call them islands. So on this design here, I can see that my ground from my power supply is well connected to this ground over here. It will go up around the top of the board and get through to there. This pad will come in kind of up through the bottom side here will be connected kind of around the edge here, but maybe that's not really that great. One thing that I might like to do is actually create some additional connections between the top and the bottom ground planes, maybe like kind of down here somewhere. So I do that by placing a via. So via here, I need to choose the net again. This is a mistake that some new designers might make, is not actually specifying the net for this polygon. So I need to choose here ground. I need to choose a hole size, so something a little bit smaller. And I also need to choose the diameter, the expansion of that, which will be kind of the exposed region around that via. So let's say like 1.2 millimeters, something like that is fairly reasonable. And I can just click and place that here. Now, a few things that I need to point out about polygons. So basically, first of all, once you place these polygons, it's kind of hard to see what's actually going on because now this red color kind of covers everything. So there's an alternative view. So if you right click, open this PCB standard menu and choose transparent 2D from that menu, then you actually kind of get to see through the polygon, so you can kind of see a little bit better. But if I actually start moving things around, then you notice that for example, if I move this capacitor over, you notice that the polygon is not really being redrawn. And so to make that happen, what I need to do is re-pour the polygon. So this is polygon pause and re-pour all, and they will all be recalculated. So when if I actually need to make further modifications to my circuit, I will find that I need to kind of get rid of these polygons because they kind of get in my way a fair bit. And so I can do that polygon pause and shelve the polygons, and that kind of just hides them for a while. And then I can keep working, and then when I'm ready, I can restore them and bring them back. Now the green color here means that the polygon needs to be recalculated or re-poured, so that would be re-pour all. Now you find yourself going to this menu all of the time, so it's kind of useful to know about some keyboard shortcuts. So you see that on these menus here they have an underlined letter, so for T for tools. So if you have your mouse cursor just anywhere, you're doing some work, if you press T on your keyboard, it opens that tools menu. And then again you see the underline, so G for polygon. And then again you see the underline, so if I want to shelve it, that's H. So that was TGH. And so TGE will restore, TGA for repouring. So you kind of find yourself using these keyboard shortcuts all the time, so it's useful to remember. So TGA to repour your polygons, for example. Useful to remember those. So there's a few things that I need to do to kind of finish up this board. So most of the time we would like to place something on the Keepout layer around the outside of the board. And so this again depends on your manufacturing process, but for us it's helpful if you have this Keepout layer defined around the outside of your board. So you can actually go place Keepout and track, and you can draw around the outside. But again, there's actually a smarter way. So design board shape and then create primitives from board shape, and then a width. It doesn't really matter what the width is, but we'll place that on the Keepout layer, and that will then draw that feature around the outside. It's green because it clashes with my polygons, which need to be repoured. And so there we see that Keepout layer feature around the outside of my board. Save that. The last thing that I need to do is a design rule check. So tools and design rule check. So if I run the design rule check, this dialog is a little confusing. If you press OK here, it does nothing. You have to press this one on the left that says run design rule check. But what I'm going to do is turn off this create report file. In fact, first I'll show you what report file means. So I run design rule check, and I get two things. I get this messages view, which is my list of problems. I'm just going to put that down in the bottom here of my window for now. And I get this kind of HTML file with a list of all my problems, which I personally don't really like. I prefer to use the messages tab, where you can double click and it zooms you into where the problem is. And the problem is, of course, that pin which I forgot to connect before. So I'll just go back into design rule check. If I turn off this create report file and hit run design rule check, then it keeps me in my PCB, which is a little bit nicer. So I need to obviously route that track. So let's go rank that connection from here to here. So that was Control W to bring up the drawing a wire, drawing a track. Click that in, little green color here because we're clashing with that polygon. So TGA to redraw my polygons, and the error still stays there. So we actually have to run our design rule check again to get rid of that error, and I see no error here, and so that actually looks pretty good. So there we go. I'm fairly happy with that printed circuit board now. Number 3 key will show me the 3D rendering, and that's what my actual design is going to look like. So there we go. The final thing which would be helpful to do would be to label these pins. So somebody who's using this doesn't know that that's the input and that's the output, and which one is +12 and which one is -12 and so on. So on the top overlay here, I should place some text. So place my string. Here it says ground. I can just click. If I hit tab, again I get my description over here, and I can write in a label for what this is. So input will go here, and so on. So I'll just go through and set up all of those labels for the other parts of my board. And once I've done that, I'm pretty much finished, and this board is now ready to be made.